Alright, family, I welcome you once again to another exciting revision in Mathematics Paper 1, where we are going to answer a question that came under Earth Geometry, specifically in Paper 1. Okay? So the question says, the diagram below shows the position of towns A, B, and C on the surface of the Earth. Okay? Next, in the prime meridian. We have already been told to say this NAX stand for N stand for north, then A stand for this point that is right here, then C stand for this point that is right here, and S stand for south, for the south. Okay, so these points here, they were aligned on the prime meridian. That is what we have been told. All right, now as you can see here, A was lying on the latitude of 60° north and the longitude of what? 0 degree. Okay, see, it was lying on the latitude of 30° south and the longitude of 0 degree as well. Okay, then for B, it was lying on the latitude of 30° south and the longitude of what? 30° what? West. Okay, so what you need to understand is that latitudes, these are imaginary lines that run from west to east. Okay, so this is a latitude here as well as this one. Then when you talk of longitudes, longitudes are imaginary lines that run from north to south. So this is a longitude right here. Okay, that is what we have on the diagram. Now the first question says, a ship takes 26 hours to travel from B to C, a distance of 1,560 nautical miles. Okay, find the speed of the ship in knots. So they want us to calculate the speed of the ship in knots. Now remember, we have already been told to say this ship takes 26 hours to travel from what? From B to C. So meaning to travel from B to C, it takes 26 hours. So that is the time difference there. In this 26 hours, it covered a distance of 1,560 nautical miles. So this is the distance that was covered. So they want us to find out the speed in knots, the speed of the ship in knots. Okay, so to calculate the speed of the ship, allow me just to group the data, just for the sake of understanding here. I'll just group the data. So for business, you can use this line here. We offer both physical and online lessons. So the first thing that we have been given the time. The time difference given is 26 hours. Okay, let me just push it up there. Okay, so the time difference given is 26 hours. Then apart from that, what else have we been given? We have been given the distance. The distance is actually 1,560 nautical miles. All right. Then apart from that, we have been told to calculate the speed. So the speed we don't know. Okay. So based on the data that we have, we can form the formula. We can form up a formula which is speed is equal to distance over time taken. Okay, speed is equal to distance traveled over time taken. So the distance that was traveled was actually 1,560. We are dividing by the time taken, which is what? The time taken here is 26. Now here to divide, we need to divide here. Remember, this is paper 1. You don't even have a calculator. All right. So here, you know that 26 can go into 156 how many times? 6 times. So here you can simply reduce by saying 26 here, 1, 26 there, 6. Okay. So you're going to remain with something as 60 over 1. Okay. So when you try to divide here, your speed will be finally equal to 60 divided by 1, you are going to get 60 knots. Remember, the speed given, we have been given the SI unit in knots. And I even emphasized in the other video that I did to say when you are calculating the speed in knots, there is no need to add hours here. I've seen many students who make mistakes by adding hours here. These knots here, the one that we have been given as knots already represents knots. This knots here simply means nautical miles per hour. Okay, it means nautical miles per hour, so there is no need to add hours here. All right, hopefully you have gotten 1 or 2 points there. Allow me to proceed. In the last question given, we have been told to say, if the local time at A is 10:30 hours, find the local time at B. Okay, so if the local time at A was actually 10:30 hours, they want us to calculate the local time at B. This is what we have been told. Now, here to calculate the local time at B, here, first thing we are going to find the theta, or rather the angle. Okay, so when we are calculating the time, we always use longitudes. So in this case, we are just going to ask ourselves to say what is the longitude for A. So the longitude for A is actually 0 degree. Okay, so here you can add plus. What is the longitude for B? The longitude for B is actually 30 degree. Okay, so when we add here, I believe we are going to get 30 degree as the angle difference between A and B. So now when you get the angle difference, the next thing that we are going to find is the time difference. Okay, so the time difference, to get our time difference, we are going to say time difference, okay, time difference is equal to theta over 15. Okay, so from here I'm just going to say what is the theta, or the angle. The angle given is actually 30. We divide by 15. So this is going to give us 2 hours. This is the time difference. Okay, this is the time difference here. Now, upon getting the time difference, the next thing that we need now is to calculate the time at B. Now, here you need to understand, are you going to subtract or to add for you to get the time difference? Now, based on what we have been given, we can tell that the time here was moving from the east side going to the west side, and whenever time is moving from east side going to the west side, time reduces, so you need to subtract. And when the time is moving from the west side to the east side, time increases, so you add. Now in this case, since the time was at A, now they want us to calculate the time at B, meaning that the time is moving from the east side going to the west side. Or rather, let me put it simple for you to understand. Whenever the time is moving from the right side going to the left side, you subtract to get the time. Okay, you subtract to get the time. Then when the time is moving from the west side or from the left side going to the right side, you add. Okay, so from the right side to the left side, you subtract. From the left side to the right side, you add. In this case, the time is moving from the right side to the left side, so we need to do what? To subtract. Okay, so here we are going to say the time given at A was actually 10:30, so we are going to say 10:30, we are subtracting by 2 hours there. Okay, so this is going to give us 0 there. Then here we get a 3, then here we get 8. So that simply means that therefore the time at B, okay, the time at B was actually 30 hours. This was the time at B. Okay, so this is what I had prepared for you in today's session. Hopefully you have gotten 1 or 2 points. Thank you so much for watching.